cross-modal association and duty lines. Composition Unit, the Sydney Conservatorium of Music, the University of Sydney, Sydney NSW 2000, Australia, http://www.dsdex.com, email, stes@nospam.dsdex.com, abstract. The cognitive characteristics of the rare perceptual condition known as synesthesia provides a clinical insight into the relationship between the various human sensory modalities, and in particular for the relationship between audition and vision. Following a discussion of the nature of synesthetic perception, this nature is discussed within the context of the relationship between auditory and visual arts. 1. Introduction. Traditionally, the arts have been separated into disciplines delimited by medium and other criterion. Painting and music, for example, are delimited by, amongst other things, the different senses by which they are perceived. We hear music and see painting. One of the great dreams of the Romantic tradition has been that works particular to each artistic discipline might be meaningfully represented in another artistic discipline. One of the great challenges to the interdisciplinary translation of artworks has been the development of a system of mapping perceptual attributes between each of the 5 human senses. Whilst mapping between sculpture and painting may be achieved in a very literal way, mapping between music and painting has always presented itself as more of a challenge. A study of human perception, especially as it pertains to the relationship between audition and vision, can prove very useful toward this end. 2. Clinical Synesthesia 2.1 Human Sensory Systems. Human sensory systems mediate 4 attributes of a stimulus that can be correlated quantitatively with a sensation: modality, intensity, duration and location. 1. The attributes of intensity, duration and location apply to all 5 sensory modalities: vision, hearing, touch, taste and smell. Each of these sensory modalities has submodalities, which in the case of vision include color, whilst in hearing they include pitch. Our perception of light arrives to the brain by a series of photoreceptive rods and cones in the eye. Audition, on the other hand, uses information gathered by mechanoreceptive hair cells in the ear that measure vibrations and air pressure. The nature of the differences between the 5 modalities is suggested by the disparate nature of these sensory receptors. Whilst both photoreceptors and mechanoreceptors measure intensity, location and duration, they both also measure a property of frequency. Pythagoras, Sir Isaac Newton, and numerous other physicists have hypothesized about the existence of a physical relationship between the frequencies of light and sound responsible for the submodalities of color and pitch. However, explanations of the relationships that exist between sensory submodalities have been made in more recent times by psychologists and neurophysicists. 2.2 Definition of Synesthesia. Synesthesia is a word derived from the Greek words syn, meaning together, and aesthesis, meaning perception. It is used to describe the involuntary physical experience of a cross-modal association. That is, the stimulation of one sensory modality reliably causes a perception in one or more different senses. 2. For example, a synesthete will see colored shapes projected into their field of vision as a result of auditory stimulation. 2.3 Does synesthesia exist? Synesthesia has in the past been considered a less than scientific area of research by some, due to its reliance on subjective sources for any observations of its nature. Scientists have recently been convinced of the existence of synesthesia and cite evidence in support. The impressive test reliability and the consistency of colors triggered by different words. In the case of colored hearing, the similarity of reports from different cultures and different times across the century. The consistency of sex ratio, it is overwhelmingly a female condition. The familial pattern to the condition. The neuroimaging data, using PET, showing different cortical blood flow patterns in women with synesthesia in comparison to women without the condition. 2.4 Clinical diagnosis of synesthesia. Psychologists and more recently neuropsychologists have documented the nature of synesthetic experience in a useful manner for over 100 years. Varying criteria has been applied to the diagnosis of synesthesia, although in general psychologists have always differentiated clinical synesthesia from metaphor, literary tropes, sound symbolism, and deliberate artistic contrivances that sometimes employ the term synesthesia to describe their multisensory joinings. Dr. Richard Synesthetic has proposed 5 criteria for the diagnosis of a type of clinical synesthesia called idiopathic or developmental synesthesia, as opposed to acquired forms of clinical synesthesia such as drug-induced synesthesia, epileptic synesthesia, and synesthesia due to acquired brain lesions. Synesthesia is involuntary but elicited. Synesthesia is projected. If visual, a photon will appear outside the body in the region close to the face. Synesthetic percepts are durable and discrete. The associations for an individual synesthete are stable over their lifetime. If a sound is blue, it will always be blue. Synesthetic experience is memorable. Many synesthetes exhibit hypermnesis. Synesthesia is emotional in nature. A synesthetic experience is accompanied by a sense of noetic certitude. 2.5 Non-uniformity in synesthetic perception. In addition to these characteristics, it should be added that there is no uniformity amongst the experience of synesthetes. Each individual experiencing synesthesia experiences it in a unique form. In fact, this rather glaring problem, that 2 individuals with the same sensory pairings do not report identical, or even similar, synesthetic responses, has sometimes been taken as proof that synesthesia is not real. 3. Yet it remains that certain patterns have remained constant in the statistical information derived from scientific observation of synesthetic perception. Some of these patterns, such as the correspondence between pitch and visual brightness, have been documented repeatedly since they were first described in the experiment of Euler and Lehmann in 1881. Lawrence E. Marks describes the situation thus: one should not come away with the impression that all our knowledge about our sensory and perceptual experiences can be captured in a set of independent, or even interrelated, verbal categories, nor that sensory perceptual experiences themselves reduce in any simple manner to a list of attributes. Still, the study of synesthetic metaphor may serve as a useful model system. By being amenable to psychophysical analysis, synesthetic metaphors not only permit ready quantification, but enable us to assess development trends in the ways that at least certain aspects of such metaphors are interpreted. A psychophysics of synesthetic metaphor as described here may eventually reveal much about perception and language, but to appreciate the depth and the extent of human metaphorical capacity will demand a psychological analysis that is as yet hardly dreamt in our philosophy. 2.6 Explanations of synesthetic perception. Over the past 200 years, a number of hypotheses have been put forward to explain the cause of synesthesia. Current theories, however, in some way recognize the findings of recent neurological studies that suggest the possibility that the executive areas of the human brain, primarily in the frontal lobes,